Hi, in this video we are going to look at a question that appeared in the Contingencies exam September 2018, question number 6. It deals with mortality rates. It's a pretty easy question. It's a cookbook type. All you need to know, or rather all you have to do, is recall the formulas and plug the numbers in and you are done. Let's start. In part 1, we asked to define, showing notation, the directly standardized mortality rate. I'm going to call it DSMR, the directly standardized mortality rate. And in part B, the indirectly standardized mortality rate. Okay, this is just my notation. It can differ in books. And of course, in part 2, we are asked to calculate these rates for occupation A using all occupations as the standard population. So we'll run through the calculations rather quickly because it's just an application of formulas. Okay, let's start. The DSMR, the directly standardized mortality rate, is given by this formula. Basically, it's the weighted average of the central mortality rates using EXT upper C for standard populations as weights. Again, this DSMR is the weighted average of your central mortality rates using EXT upper C, which is the central exposed to risk for standard populations. Okay, before we go any further, let's just remind ourselves very quickly of some notation. MXT is the central mortality rate for the population being studied for ages between X and X plus T. And this notation here, EXT upper C, this is the standard notation for central exposed to risk. This S here means that we are dealing with the standard population and we are looking at ages X to X plus T. Okay, just to go down a little bit, I've also made a couple of remarks here. Make sure you know the notation really well. This central exposed to risk here has a S outside here, which means that we are talking about the central exposed to risk for standard populations. Without the S is just for the population being studied. Okay, now let's get back to the problem. By way of definition, DSMR is written like this. Okay, like I said, it is the weighted average of the central mortality rates using your central exposed to risk for standard populations. Okay, now all we need to do is just let's work this out using the data given. So we have got this number here multiplied by this number here. This denominator here is given to us. How much is that? Good, because we are using all occupations as the standard population. Okay, so this number here, nothing to worry, just plug it in. Now we need to do a little bit of calculator work. Let's pick out the numbers. For the first case, 140,000, that's your EXT upper C for your standard population for the age band 40 to 49. Let's start there. Multiplied by your central mortality rate, and that will be for the population being studied, which will be 125 divided by 10,236. Again, the population being studied is occupation A, so MXT for this age band will be 125 over 10,236. That's what you see here. Do the same for the rest of the age bands. Next one will be 156,000 times 156 over 11,256. And finally we have 168,000, excuse me, let me say it again, 168,000 times 166 over 10,633. Clean this up, use a calculator, and you will get your answer 0.013997. Again, 0.013997. Pretty easy to do. According to the examiner's report, many people had this question perfectly done. Okay, let's deal with the indirectly standardized mortality rate, ISMR. This one here must be careful. It's again an application using a formula. We have a numerator here and a denominator. So it may be in your interest to work it out separately and then work out the final answer. The numerator here is the crude mortality rate, again, is the crude mortality rate for a standard population. And the denominator here is just your expected deaths over your actual deaths for the population being studied. Okay, so let's work out the numerator first. So we need, remember we are working out the crude mortality rate for the standard population. Remember what is crude mortality rate? Crude mortality rate is your actual deaths over your total exposed to risk. That's it. Okay, so except that now we are dealing with the crude mortality rate for the standard population. So let's do that. Let's move it up a little bit. We will take this number multiplied by this number. So this number is given to us. You can see it in the table. So 140,000 times 0.00169. That's what you see here. Go to the next one. 156,000 times 0.0022. That's what you see here. And then we have 168,000 times 0.00277. Remember, there is a number here which we know it is 464,000. So that's the numerator. If you work it out, you will get 0.0022525. Now we need the denominator. Now the denominator, we have EXTR per C times your mortality rate for the standard population, because it's the expected deaths, divided by your EXTR per C times your central mortality rate for the population. Now this thing here is your actual deaths, so you don't have to worry too much about it because the numbers are given 447. So that's easy. You just have to work out this part here. So take the first number, which is 10,236, multiplied by your central mortality rate for the standard population times this number here, 0.00169. That's what you see here. Do the same for the rest of the age bands. Take 11,256 times 0.0022, and for the final age band, take 10,633 times 0.00277. Remember I told you this number here we already have. You can actually work it out, but you'll get the same number anyway. So it's 447. Plug the numbers into your calculator. You will get the value for the denominator as 0.159989821. All that's left to do is work out the ISMR, write the numerator over the denominator, use a calculator, and you'll get 0.014079, and you are done.